Hey, everybody. We are back for, I think, the third VOD in 24 hours. This is the first. I'm super excited. We need to have more 3-day weekends, I guess, so I can do more work, as it were. But I want to do one final doggy. No. Come on. Come here, buddy. Come on, doggy. Come on. Come on. Doggy. Come here. He hears the he hears the adult voice and he just wants to run. Why do you want to run away? Everybody loves to see you. It makes the video so much better. That's right. Okay, let's see if we can get him to stay with us. But I want to quickly go over, now that we understand general principles of software architecture and software design a little bit. By the way, if you're looking for a really good software design book, I strongly recommend the Design Patterns book by the Gang of Four. I'll Google it here in a second when the doggy's not on my lap, but I think it's called Design Patterns, and it's lovingly referred to, I think, as the Gang of Four, because I think there's 4 authors, and it's one of the first design patterns books that I read and helped me start to reason about different ways to design software, more than just write code, but how to design it in a way that is following those principles we talked about on making it easy to iterate and easy to adapt. There's also a book. This is not for the weak-hearted. There is a book called Modern C++ Design, I believe, by Andrei Alexandrescu, which is a phenomenal book, but it is not easy. If you have not mastered the basics of C++, this book is likely going to confuse the heck out of you. So if you're just beginning in C++, I do not recommend this. There's several others that you should read that are much more, they're designed to be more accessible for like entry-level programmers. And by the way, we all go through the entry-level phase. This isn't me disrespecting you. There's just a core amount of knowledge we tend to need to have before we can get to the advanced material. Again, while I can teach you about neural networks, if you don't understand linear algebra, differential calculus, as well as multivariate calculus, and the fundamentals of machine learning, it's going to be really hard. So that said, if you are very strong in C++, I recommend looking at Modern C++ Design if you haven't read it. There's some interesting stuff in there. I feel like it's on the level of like the Gang of Four Design Patterns book. Now he's getting so comfortable, he's falling asleep on my leg. So I don't know if I'm going to be able to type. Yeah, buddy, I'm talking about you. Look, he's like right here. Yeah, okay. You can go back to sleep. So what was I saying? Yeah, it's like taking some of the concepts maybe from Gang of Four in the design patterns and then showing how some of them or some deviations potentially can be done using advanced template metaprogramming in C++. And there are some pretty cool ones, I think. Like one of the more interesting ones, I think, is like there's like a policy mechanism that I think I used, and it confused the heck out of a lot of people. But it is actually really, it's clever in like its potentiality, but it's also hard. So other people may have trouble understanding it. And then on top of that, there's, I think they talk about the visitor pattern in modern C++ design, and I think they also talk about the visitor pattern in the design patterns book, the Gang of Four book. So there's some overlap. They're not like a one-to-one mapping, but both are quite good. Design patterns is meant to, I think, be used for many different object-oriented programming languages. I think that's the principal target audience, whereas modern C++ design is specific for C++. Maybe you could do some of the stuff with Java generics. You could maybe do some of it in C#, but the original target audience was C++. Okay, so that being said, aside from those books to understand software design and how object-oriented programming can help, I tend to think of OO as minimally helping with these three areas. I think, one, it tends to be less of a mental burden to reason about code. That's OO. That's my strong conviction. And I haven't tried to like empirically demonstrate this, as I probably should as a scientist, but in my heart of hearts, it's easier for me to reason about code that is OO. And that's largely, I think, for these two following reasons. There's some other reasons, but I think these two are critical. The first is data encapsulation, and the second is interfaces. Now, before I get trolled by the non-object-oriented folks, especially from the C community, who I love, and major respect for you guys, because without C, we probably don't have C++. And many of the core concepts come from that language, as I think Bjarne even calls reference to. I will say that I still think that even with the evolution of things like structs inside of C++, which supposedly they're essentially identical, classes and structs are identical, with the exception of the access, the default access privilege level is different. In objects, I think the default access level, when it's unspecified, is private. And in structs, I think it's public. And so in theory, you could have a struct do everything that a class can do, as long as you just specify the access control of being private right out of the gate. However, I would argue that the concept of structs historically have seemed to imply that they are, I mean, this is how they were used historically, is they are structures that are data types. They're data structures, and that's basically what they are. And that's how they functioned in C for a very long time. I don't know if they've been updated to do more in C, like if you can put functions inside of them. I wouldn't be surprised. But historically, this was their original design, and this makes sense, especially when you think of programs can be broken down essentially as two pieces, the data structures and the algorithms. So the structs are the data structures, thus the word struct, and then the actual functions that exist in C are the algorithms. And there you go. You have those two things and you've got everything. With object-oriented programming, the fundamental difference is you get both of those things together. You get basically the algorithms methods, which is a slightly different concept than functions. I mean, if we want to split hairs, functions, I think in their purest definition for procedural languages or object-oriented languages, they are free-floating procedures that can be executed potentially at some predefined scope, whether that's inside of a namespace, inside of a compilation unit, or globally. You can call them. Methods, on the other hand, are essentially procedures that have binding to classes. And without a class or a class scope, then you cannot call these things. So if you have a method inside of a class, let's say in this case it's a static method, so it would be something that you would scope resolve as being like part of this class. Like let's say it's a factory, so it's going to construct a new instance of this thing. You have to essentially specify the namespace of the class, : the method. If you try to call the method just globally, it doesn't work because it doesn't exist in that space. How is this helpful? It helps you reason about programs in a slightly different way, because the algorithms tend to, not always, but tend to be scope resolved with the appropriate class that they live inside. Now, I'm of the mind that pure object-oriented languages like Java, I think, are too much. I think C++ does it right. And I don't know if I think Go also does it like this. And I'm not sure about C#, but I'm fairly certain about Java, is that Java, everything is a class, even the core object thing. And so basically all the functions are essentially methods. There's no free-floating function. Even like main, I think, lives inside of like the main class or something of that nature. I actually think that there are cases where having free-floating functions that, I mean, they can be in a namespace, so they don't necessarily have a binding to a class, I think kind of makes sense. And an example of that would be the standard template library algorithms collection. So things like sort or other algorithms that I can't think of off the top of my head. Reverse, this type of thing, where it's like you could have like an algorithms class, but this seems a little strange because that seems a bit presumptuous that like all the algorithms for the whole world kind of live in this thing. So I think having it in like the stud namespace makes a lot more sense because this is kind of like the standard. Anyway, I'm digressing a little bit, but my higher order point is that the way that OO helps us, I think, that is a huge step forward over procedural programming, is the reduction of the mental burden. It allows us to reason about things in a much more simplified and organized way because we are thinking about classes, and classes kind of have essentially these two things. They have attributes and they have methods. They have attributes or they have interfaces. And the way that I code the classes is that the attributes are almost always fully hidden. This is super important in my mind. Not always. There are cases when you can have data that you are going to expose. Statics, sometimes static variables inside of classes sometimes make sense to be at a protected or a public level. Things that are mutable can make sense to go in that space as well. But oftentimes things that are instance-based, so they are things that get constructed each time you create a new instance of the class, those things I think tend to be better placed inside of the private or protected sections, not in the public sections of the class, because they force access patterns through interfaces to get some sort of access to that data. This is super important because that level of indirection, that level of abstraction allows you to change the implementation of the data and its structure, just all kinds of things behind the scenes, which increases the iteratability and the adaptability, essentially the adaptation of that software. And you may be wondering too, like for the 3 pillars of machine programming, why we have this entire pillar, right, of this is like a new feature that Google has, and I don't like actually need this. I just wish it would do its thing. Okay, so in this paper here, okay, that's cool. We have the adaptation pillar. So, yeah, I'm already paid for it, guys. What are we doing? Okay. In the 3 pillars of machine programming, we have intention, invention, adaptation. Intention is basically trying to understand what are we actually trying to build. Invention is the process of actually building it. And then there's a whole pillar just for adaptation. This is why. Because I would argue that the majority of software development is not really in this invention space. This is why I tend to be not super stunned about the code generators, because most of the code generators work on a blank slate of code, which is pretty easy in my mind. Like, it's much easier to write Hello World from scratch than to figure out how to inject Hello World into a 1,000,000-line program. Therefore, the adaptability piece is very complicated, and that's why we have essentially an entire pillar for this. Okay, so with that in mind, these things are helping significantly with iteration and adaptation. The data encapsulation and the interfaces. Interfaces force a common API to communicate to these classes, and the data encapsulation ensure that only the interfaces are used and the data cannot be accessed directly. And curiously enough, I would argue that Jeff Bezos is probably a big fan of object-oriented programming, whether he realizes it or not. And I say that because of his famous mandate at Amazon in 2002, requiring that all teams communicate with each other through publicly exposed APIs, not allowing them to send data directly to each other. This was super, super important. And I love this because this is, in my mind, a big reason why I love object-oriented programming is, as I'm arguing here, the data is encapsulated, so the only way to get access to it is by using interfaces. That's basically, as I understand it, what Bezos was arguing back in 2002 and why he wanted these APIs. Oftentimes, people will say that this API manifesto was the beginning of Amazon Web Services. AWS. Is that what it stands for? Amazon Web Services? I have to know now. Yeah, okay. For some reason, that just sounded really strange for the moment because I think of AWS as being so much more than web services. But you can kind of see how this is like the beginning of AWS because you're now forcing APIs to be the vehicle of getting access to data. That then forces you to standardize the APIs that are going to be used inside of the company. That then basically creates this agreed upon body of communication that then the whole company will start to use. And if the entirety of Amazon is using this, then suddenly the next question is, could you make this public? And could other people benefit from this? And I think that this is like one of the things that they did. Let's actually take a look real quickly to see if other people found. I thought that this was part of the story. In 2002, according to Tech Legend, mandate was issued by Bezos. Mandate, also known as Bezos API mandate. Amazon API mandate was serves as the backbone for Amazon in modern web space. Okay, cool. Yeah, so this is like it may be a little bit of lore. So there's like this mythical part of it, but I do think that this is possibly the beginning of Amazon Web Services. Yeah, this thing. And on top of that, this has been my experience to build wildly adaptable and iterable software. That when you follow this principle and it's mandated that you can't take shortcuts, incredible things happen. Like truly phenomenal, wow, this is great stuff happens. And so teams must communicate with each other through these interfaces. There'll be no other form of inter-process communication, no direct linking, no direct reads other teams' data store, no shared memory model, no backdoors whatsoever. The only communication allowed via service interface calls over the network. Man, that is awesome. I mean, crazy. The foresight to, doesn't matter what technology they use, HTTP, Corba, PubSub, custom protocols, doesn't matter. Yeah, sweet. All service interfaces by exception must be designed from the ground up to be externalized. Oh, okay, cool. Team must plan, design, and be able to expose interfaces to developers, the outside world, no exceptions. Woo, okay. So it was part of the plan. This is great. Anyway, the takeaway from my perspective is that when you are using OO the way that I envision it, you follow these same principles. And my experience has been, this is a game changer for writing code that is going to be iterable and adaptable in ways that are simply not possible if you don't follow these principles. Now, what's tricky is the way OO is designed in most systems today is it's relaxed and you don't have to do this. So it's not as hard a mandate as what Bezos is doing over here. You can say, oh, okay, well, I'm going to create these interfaces, but I'm kind of lazy, so I'm just going to expose this one thing. Again, I get it. I write software too. I probably, if you look at Datsa, there's possibly cases where I expose things in a public way that I shouldn't. My hope is that whenever you look at my open source code, mostly you see it's done like this, is that you'll have, there's a spider on the ceiling approaching me. That's pretty cool. He's coming for us. Clearly, I'm not too afraid of spiders, but he did catch the corner of my eye. So these are our interfaces, right? These are all public, but then notice the actual data. It's all here. There is, nope. I'm trying to see if there's any data members. No. There appear to be none. They're all private. So cool. That one passes our sanity test. We'll now go to this data generator guy. Let's see if this passes our test too. We've got some constructor, destructor, blah, 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 blue, blue, blue. We have a whole bunch of things. Okay. And then we have private, and we've got our members. We've got our members. We've got our members. Yeah. Okay. So all of our members are sitting down here. By the way, this is what I think like this is gonna. I don't mean this. I don't mean for this to sound arrogant, but it may come off arrogant because I'm talking about my code. But what you may notice is that most of my code is not documented. I'll put like these little breaks so I can have separation of concepts, like these little lines. And so once in a while, I'll put like a comment. But most of my code is kind of like if we go back to, I forget what file we were looking at. Let's start with maybe this data entry. Yeah, this is a good one. There's like 2 comments in the whole file, right? So like I'm not like I'm gonna write a comment for this. Nope, I'm not. And I had to do these headers because Intel was keen on that. So I'm not saying that you should not comment your code. Absolutely think that you should. But what I would argue is that for the super seasoned programmers, the people that are like master level, you will occasionally get something like this. You will get a massive comment across something that's like, why is there this huge comment for this variable? The reason for that is that this is going to be extremely complicated, and that master level programmer is trying to help you, trying to say, listen, you may not realize this, but this thing is way more complicated than everything else. All of these other things are going to be really easy to understand. This thing is not. So I'm going to write 2 paragraphs to explain what this thing is, so you get a sense. So then when you see it in the code, excuse me, when you see it in the code, you understand that this is very complicated and doing some pretty wacky things. And it does. That when you see how respect windows is used in the actual code, it's like very hard to understand because it is doing some stuff that is, there are multiple things that it's trying to reason about, and it just overrides certain behaviors that like are non-intuitive. But if you understand the design and you understand this comment, then it'll make sense. So just as an aside, I think that this is, if you see code that looks like this, where a lot of it is uncommented, and then you see there's like this major comment over something that's like a variable, my experience has been you should really pay attention to that comment. And that's actually exactly what I was doing here. There's like some other cases, I think, when I'll have long comments. Yeah, like this right here. This is another one. This is actually super important. The type of uniqueness, if it's hard uniqueness or soft uniqueness. If you don't understand this concept, you will not understand how this uniqueness enumeration works for data generation. If you do understand this, then the whole system will probably make sense. And if you reference the actual dots system, I think, well, we talk about it in the actual paper somewhere. This might be just the original. Oh, yeah, here we go. Here, it's right here, data uniqueness. So it talks about hard and soft uniqueness. Hard uniqueness is basically if it attempts to do uniqueness, which guarantees the value will be unique in the data set, and it's unable to generate a unique value because the constraints of the unique numeric generator have been exhausted, meaning there are no left numerics that can be used in the set that you gave it. Hard uniqueness will say, I'll exit now. I will terminate the construction of the data set because this is a hard uniqueness property that I must follow. Soft uniqueness says, I will try to generate unique numerics, but once I exhaust the supply, I will then accept whatever the next number is, and I won't end the program. I'll like try to iterate over the number of retries that the programmer specifies, but once I exhaust that, I won't terminate the data generation. And this is actually super important because in some cases you really do mean I need this to be unique. And if you can't make it unique, you need to just stop and we're going to start over. In other cases, it can be like, I want this to be unique, but I don't need it to be unique. And so a good example of this would be, I think, the difference between hard and soft real-time systems. So a hard real-time system says that you must execute certain functions in a constrained period of time, and it is a violation of the execution of the program to not meet that criteria. Like literally, I think in many cases, the systems will like terminate, or they will guarantee essentially that it must be satisfied. So systems that hard real-time systems that control things like airplanes or space shuttles will follow this, is that they must meet this criteria. Soft real-time systems are things like Netflix, where they're trying to guarantee a certain amount of fidelity in a real-time capacity, but there may be external factors that cause them to degrade, like your internet fidelity or your ISP's internet fidelity. So then what they'll do is basically say, well, I want it to be at 4K. That's where I'm supposed to be, but the state of the universe is pushing it down to 480p. And so I'm just going to do that because that's the best I can do right now. So that's an example of like a soft real-time system, is it won't terminate the program and say, stop, just quit out of Netflix. Whereas like the space shuttle system will say, nope, this has failed, go to the redundant system, this kind of thing. And you can kind of understand is that the hard real-time systems, it's sort of like, okay, people could die. You need to make sure that these things are built. And so if the main system is not meeting it, switch to the redundant system. Netflix, it's sort of like, okay, well, what do you think the person wants? Netflix to stall out and have them watch nothing for 30 minutes, or degrade the quality of the video from 1080p to 720p or something for the next 15 minutes, and then it's going to jump up. I think that a lot of people would probably say, okay, just have degraded quality for a little bit. So similar principle is happening here. And this goes back to this whole concept of why you'll have little snippets of comments that are really important. And you generally will notice that this entire file, there's basically no comments except for this one comment. And again, it took me like maybe 2 or 3 minutes to explain this. When we go back to this other guy and we go back to the respect windows, this comment is much longer. I would actually have to read up on this and understand what it does. It is like super wacky. Anyway, I'm deviating a little bit, but hopefully this demonstrates the higher order point that I try to follow this in my own code. And the reason why I do it is I think that I follow both Bezos and I think it's Reid Hoffman's view that software should be iterable and adaptable. The goal with software, in my mind, is not to solve a problem. That's super easy. Like, this is a piece of cake. Writing a piece of software that solves something is like child's play. Writing a piece of software that is designed in a way that is massively extensible and future-proof and automatically evolves itself without you writing much code at all, that is like ninja level expert stuff that very few people I think on the planet can do. But if you can learn how to do it, like you're 100x, you're 1000x coder. Like the likelihood that any of these AI systems could function at that level is probably approaching zero. That's how much of a superpower this is, because this is very complicated. It requires massive levels of discipline, and it also requires you to deeply understand principles, not just what the syntax is to fulfill some high level goal, but to understand principles, like first principles on how overall systems should be designed. And you're fulfilling those across these large swaths of code. And then once they're achieved, then you have like this magnificent system that you know is going to scale, I think, really well. Anyway, I think that's basically all I wanted to say for our third VOD of the day. And thanks everybody for the fun and excitement over our 3-day weekend. And intractable, or sorry, my friend, I keep messing up. Hold on, let's go back over here. Let's it's this video, I think. Untranslatable metaphor. By the way, the reason why I get this sort of wrong is there's a few different words. There's like intractable, and I use this word all the time because it means something specific for computer science. Then there's this other word of like interpretable, and there's this notion of uninterpretable. This is like interpreted languages and these types of things. And then there's also this notion of like translation, like transpilation. And so there's is it translatable? Is it untranslatable? So in my head, I've got 3 different things that I'm struggling with, and I can't remember which one. Maybe I'm just going to call you Mr. Metaphor or Metaphor Person, something of that name. We'll have to come up with a nickname for you, like we do with Mur. Anyway, hopefully, Metaphor, this explains a little bit on the software architecture stuff, and now the second video on object-oriented programming. There's significantly more to talk about here. This is literally just the beginning, but hopefully this is starting to chip away at some of the questions that you had. So please holler in the comments if there's more stuff that I should talk about. I actually love getting this because otherwise I sometimes kind of meander and talk about stuff that I think is interesting, but it may not have as much value to you. Okay. Thanks, everybody.